Now we are going to take a look at the custom sequence again. In the last video, we had also discussed the basics of custom sequences. But now we'll implement something like we'll implement the polygon class, right? But before that, we'll have to implement the point class. Remember, we had worked with the point class. We had created the point using the named tuple. Here we'll go through the point like class-based implementation, right? Now, again, in any point, so any point is referred to have the two value x and the y. So we'll only work with the two-dimensional space, right? So again, so this is the extension of the custom sequence class that we had seen in the last lecture. Now, first we'll need to test how we can like how this if type of numerical real number or not. So first we'll need to see that how we can test if a type is a numerical real type or not. For this we need to know, or we need to understand this number module. Here first we are implementing the number modules. Let's import this, right? Now this module contains all the base types we have. It has the number type, it has the real type, it has the complex type. So you can know if the number is the real, complex, or just the number or not. So again, consider that we have this isInstance function. So here we are saying that isInstance 10 comma number dot number. Here the number is a type. So this will give me true because 10 is a number. 10.5, this is also a number. This here we're getting true. 1 plus 1j, this is also a complex number. Again, we are checking that whether this value is a number or not. We'll get in true over here. Now we want our point to be real number only. So for that, instead of number, now we are checking dot real or the real class. So here we are checking that whether this 1 plus 1j is belong to the real class or not. We'll get false because this is a complex number. Here, see this? Now we are checking whether this 10 is real number or not. We are getting true. Now whether this 10.5 is real number or not. It is. So we are getting true over here. So now we know how to test the real number. So now let's implement our point class. Now this point class have two property. One, x and the y coordinate. These two coordinates should be the real number only. And second, the point instance, that means the object of the point, should be a sequence type. That means it should be the iterable. It can hold the multiple value, right? So that we can unpack the value, right? So we have to keep this in mind. And here is the class implementations. So again, here we have this point class. In the init method, it takes two arguments, x and the y. And then we are checking that whether this x belongs to the real number or not. We are checking whether this both belongs to the real number or not. If it is not, then we'll get error. But if it is, then we are storing this x and the y object into underscore pt attribute. So this is the attribute that we'll be creating. So here we'll store the value in this attribute. Else, if we'll get over here, we'll get the type error. Here we'll say that point coordinate must be the real number, right? So it will raise the type error. Now we have the REPR method, which is just a way to display the point object. We have the length method. It returns 2 directly because we have seen that this point has to have the two-dimensional. So length will be 2 always, right? And then we also have implemented the get item method. So get item method works with the slicing as well. So if you pass the index, right, then it will give you the value of that index from the point over here, right? Now let's try to run this here. Now let's use our point class, right? And let's check that whether this is working or not. So here, first we are creating a point object p with a point class. Now let's try to print p. Here we are getting point 1 is x equal to 1, y equal to 2, because this is how we have printed, how we have returned right? Now let's try to check length of P. This should be 2. Now let's try to extract the individual value. We are extracting P0 and the P1. P0 should be 1 and P1 should be 1. And this is working because of the get item method, right? Now let's try to extract this value or unpack this value, because this point is nothing but a tuple. Here we can see that. So we are able to extract this. We can say that x comma y equal to p. So x will hold the 0th position value and y will hold the first position value. This is working. We can see that x comma y. So now we know. So now our point class is working. Now we can implement our polygon class. Now we'll essentially be, so this polygon class should be the mutable sequence of point, right? And based on these points, so these points combinedly can create a vertices, right? So let's create a polygon class. Here we are saying that polygon, then the init method, it takes the point object. So here we say that star PTS, right? This is a reference for point. And now we're saying that if PTS is there, that means if the value is there, that means this will be true. And then we are storing. So after we get the PTS, what we're trying to do is we are trying to loop over those PTS value. So whatever the value we have, we are trying to loop over those value. Then after that, we are unpacking those points. So here this point will be the object of the point. So we are unpacking those points, and then we are converting to a point object, right? And then this will be stored in the underscore PTS. Else, if you do not pass any value, it will create the empty polygon. And then we have the REPR method. Let's run this here. Now let's try to do this. So here we are creating the polygon without any points. So this will give me the this empty list. And again, in the REPR we'll get, in the bracket we'll get the empty list over here. Let's see this. Here we can see that we are getting the empty list. Now let's create a polygon class with the 2 point. Here we are passing 0 0 and 1 1. So again, remember, this is 1 point and this is another point we are passing, right? Now because this is the star operator, right, it can hold these sequences, right? And now it can take these sequences and convert this to a loop. So basically it can take these sequences and convert to a point and store in a separate list object. Let's try to do this. Here when we say P, now what we see is we are seeing the object in a list, right? Now let's try to create polygon. So first here we have the point object, now here we have the list. So both should work because we are unpacking this point in this function. If we'll unpack this, this will extract these 0 0 value and convert it to a point. So here we are essentially creating a point over here. Let's do this, and here we can see that we have the point now. Right? Now we have this again. One minor mistake is that our polygon class should so our polygon class in it assumes multiple arguments, not a single iterables. Here we have this one object, one list object. Inside this list object we have the multiple point. So we have to fix this. This should not be into the list object. So to fix this, what we can do is we have the points. So this is a list we'll get. So what we'll do is we'll kind of pass this list and join with the string separated with the comma. And then, so like this is, so we are just fixing the REPR object over here, REPR function over here, right? And then we should print the polygon, and then we should kind of pass this string to the polygon over here to this point str. Let's run this. But still, let's try to do this. When we do this, and then when we try to create P, like try to print P, we'll get error. What error we are getting? We are getting that sequence item 0 expected string instance, but point found. Here, this method, this join method, either can take string, right? Because we have this join method, so this is a string method. right? And it can only concatenate the string. So what we have to do is we have to convert all the points, right? Here we have to convert all the points. So this list point, we have to convert this to a string, right? Over here, let's fix this. So here what we have done is we have extracted all the points object. We have extracted all these object inside this object and converted to a string. So each point has been converted to a string and passed to a list, right? And now we are joining after that. Let's try to run this. Now when we do this p equal to polygon, it will create, and when we say p, now we have the polygon class over. Now it seems correct, right? Now, now we can start making our polygon into a sequence type. So now we have this. So now we can start creating a polygon class as a sequence type. First, we need to implement the length and the get item method. Here, this polygon class we have. So this is the polygon class we have. We have this point. So this init method is still the same. Repair will be the same. Now we just need to implement length method. So length method will give you the length of this list, right? So if you call the length function, this will give you the length of this list, right? And again, to implement the get item method, you just need to pass the index. So here we are passing s, and again this pts is just the list, so it will work as expected. Let's try to run this. Now when we try to create a point, here we have the point 3-point polygon. Now when we extract p0, we are able to get that. Now when we do this colon colon -1, we'll get the reverse order. All this is working because of the point we have, because this point is in the list data type, right? Now let's implement the concatenations, right? So for the concatenation, we'll have to implement the add method, right? So let's try to do this. Here again, every code will be same. Here we are implementing the add method. So first we are checking that whether this other object, so let's say that to add method, the other object will be passed, right? So other object is the instance of polygon or not. If it is, so what we'll do is we'll create a new point by taking the point of the original class and the other point, right? So here we'll add those 2 points and create a new points, and then we'll pass these points to the polygon, because this add method will always return you the new object. We have seen that. Otherwise we'll get the error. We can say that we cannot concatenate with the another polygon. So here we'll get the error. Let's run this. Now we have created a 2 polygon over here. The ID of 2 polygon we can see. The ID is this. For first polygon, for P2 we have this ID. Now let's try to concatenate this. Here we are concatenating P1 plus P2, and then we are storing the result in the result keyword. Now let's try to check the ID of the result. The ID of the result is totally new, which was expected, right? Now let's try to handle the in-place concatenations. Now in-place concatenation, now let's implement this. So again, for that we need to implement the add method, right? So here we have this add method, right? Again, so add method is still will be same. And the add method, first we are checking there whether this point belong to the isn't to this polygon object or not, right? If it is, then again here remember that we have created a new point, but this time we are adding the other points to the self or to the same object, right? And storing into the same object as well. So this is what happening over here. So we are not changing the point value. We are not changing the object address over here. Here we are not creating the object like this. Here we have created the polygon object, but here we are just adding the points, right, to the same polygon, and then we are returning the same object over here, right? And then we have got the error. Now let's try to run this. We have 2 points. The ID is, we can see, we can now here we are trying to do the in place concatenation. We are saying that 0.1 plus equal to 0.2. When we are doing this, it will call the IAD method. It will check that whether this 0.2 belongs to polygon or not, and then it will add those points right? It will add those points to this P1 point only, and then it will return the P1 object itself. So here, and then when we check the ID of P1, we can see that the ID of P1 this and this ID both are same, right? And then this 2 point x2 and x3, we can see that has been added to the polygon P1 polygon only, right? So that work. But consider this, when we do this piece, so here we are creating a polygon P1, and when we do this, P1 plus equal to this list of point we are passing. Now consider that this is not the object of polygon class. So this will give you error, because here we have mentioned that if it is the instance of polygon class here as well, then only it should work, but this will not. This will give you the error, right? We are getting the type error, can only concatenate with another polygon, right? And because we have mentioned over here the type error we have mentioned, right? So here we are getting the error, but we really should be able to handle the appending any table of points, because these two is also considered as a point. So what we want is, we want to implement these feature as well, right? And of course, this point should be the specified at just the iterable of length 2 containing numbers. So this should be the tuple inside this, or the point object should be the 2 length only, right? So what we can do is, here in the, this is the add method we have done. Now in the iadd method, right? So first we are trying to check this, right? And after that, if this is, if this is true, then it will add a point to the same polygon. Else it will take this point and convert it into point object. All of you just give me 1 minute. Now here in the iadd method, what we can see is, this was what we had implemented earlier, but in the else condition, what we have done is, we have taken the point value, we have taken this point value, take this into loop, and converted all those list of points value, this list of points value, and converted to a points. So here we have created a point object, right? So this is the list of points, and now after that, we are adding these points to the self point object, right? And then we are returning that points. So this is what we have done. So if the list of objects comes, so let's run this. So here we have this polygon, so we have this P1 as polygon of 2 points. Now here, when we are adding this list of points, so what this will do is, so here what this will do is, this will take this list, convert it into a points object, and then after that we are adding those point object to the P1. This is what we are doing over here, right? And now we can see the P1. This is the point we have got, right? Now let's implement append, extend, and the insert method. So here again, all these codes will be same, but here we have implemented the append method. So append method, so again, because we know that this point attribute is nothing but a list over here, we can directly use this list append method to append over here. So we are taking this points dot append, and then we are appending. So here we are taking the points. So what we are doing is, we are taking all these points, right, and converting to a point object, and then after that we are appending those value over here, right? Now in the extend method, it will do the same thing, but again, here in the extend method, we have taken the point. First we have checked that whether this particular object is like, whether these all those objects are point, or like belong to a polygon or not. If it is, then it will do this step, otherwise it will do the same steps that we have done. So this is very much similar to iadd method that we have implemented, right? This is very much similar method we have, right? And now in the insert method, again the same insert method we are using, but instead of just inserting point, we have converted those point to a point object, right? And now we are using the list insert method, right? So this is how we have implemented, right? Now Again, as we have seen that extend method and this iadd method have the similar code. Apart from that, iadd method returns the object and then extend method does not. So here we are just refactorizing this. So first we have implemented the extend method. This is the extend method we have implemented, right? Now in the iadd method, I'll just call this extend method over here by taking the points, right? And then it will return the self object. That's it, and nothing change over here, right? Now let's check this. Here we have the two polygon, which we can check the ID of this. So this is the ID of first polygon, this is the ID of second polygon. Now we are adding these two polygon. So this will call the iadd method, and we can check the P1 object. Again, the P1 object ID over here and over here both are same. So we have done the right implementations. Now let's see how the append method work. We have this P1. Now when we do this P1 dot append and then we are passing these two object, this like this tuple which is a point. So what this will do is this append method will take this point and convert it to a point object and then append to a this list of the polygon points, right? So it will work. We can check that we have added this point. Now even the point object can also work over here, because here we can see that, right? Now append method is also working. Now let's check the extend method. Now here we have this another polygon. We are trying that p1 dot extend p3. So this will extend or like add all these 0.3 points. So all the like, so this will kind of add this polygon 3 with the polygon 1, right? We can check the ID will still be there, like, so ID is still same. We can check that here. So we have done the right implementation here as well. Now what about this? Here we are saying that p1 dot extend and then we are passing the list of 2 points. So when we call this extend method, it will check whether this polygon, then it will do this. Otherwise it will implement the same this step, right? So this should also work. This should also work. Again, ID is still there, right? So ID is still same. So we are extending to a polygon 1 object only. Now let's see the insert work, right? Here we have this polygon 1 we have created. We have the ID of polygon 1. Now here we're saying that p1 dot insert 1 and then we are passing the point. When we call the insert method, here it is. This should take all the point, unpack it and convert it to a point object. So this will also work. This will also work, right? We can check the ID is still there, right? ID is same. Here we are kind of inserting a point object. This will also work, right? Now, so we have implemented a lot of things. Now let's see how to set items, right? How to kind of like set item with the indexing and the slices both. So for set item, we have used this. We can use the set item method over here. Again, here we can see that. Now here we have implemented the set item method. It takes this would be the index and this would be the value that we want to set, right? Now here, so when we have the index, it will pass to the point, and then when we have the value, so it can set the multiple point, right? So first, this implementation we are doing for the slicing. We are taking those point value, into a loop and then converting to a point object, right? And setting that point value or setting that point object to the specific slices, right? Now let's try to run this. Everything is same over here, right? Now when we have this, now here is the polygon. Now let's try to set with these slices, right? Because what we have done is whenever the point will come, it will take a loop, convert it to a point object, and then it will set those values. So this will work. But what happens when we set a single point value? Because we have not done implementation for that. Here a single point value will come, right? It will take this to a loop and then convert to a point, and this will be the list only. So will this work? Here this will not, because they say that whenever this will, like whenever we pass the point, it will not, so this point object will not be iterable. This point object is not iterable, right? It says that the point argument after star must be iterable, not integers. And there we have passed the integer object. So we are solving this error over here. And then in the set item, here we are checking that whether this, if this value is the integer, that means if this is a single object, right? Then we'll take this value, unpack it and convert to a point. That's it. Else it will do this step, right? So now this will work. Now let's try to do this. Here we are trying to change the 0th position value from 0, 0 to 10, 10. We can check that. We have changed it. So now it is working. But now what happens if we try to assign a single point to a slices, right? Here, of course, this should not work, right? We should not implement this, and this will not work because we have not. So here we can see that this is not working, right? Now let's try to set the multiple point on a single at a single location. This will also not work, right? Here we have got this error, and here we have got the point coordinate must be the real number. So we can fix this error type, right? Because this error is not proper. So here we can fix that. Here in the set item, first we check that. So first what we are doing is, first we are trying to solve this, like if we are getting the value, we'll take the points, right? So we'll take this value, right? Take this value into a loop, convert each point. So consider that this is the iterable, right? Like list of the values or the list of iterables. Here we are taking the point and converting to a point object, and then we are storing this RHS object. And now we are also creating another object called each, so another variable called each single, and the value is false, because this will only work if the value is not a single object. If we are trying this, if we'll get error, like again in the both type, here we have got the type error, here also we have got the type error. So if we'll get the type error, now we'll try that. So here we'll get error because the value is the single value, is the single point. So we'll try to convert it to a point, and then we'll set that each single as true over here. So we are solving both. And if this also fails, so if this also we are getting as a type error, then we should raise an error that invalid point or the iterable of points. Now this error will be quite flexible and quite understood, right? And after we get this, so whatever the value we are having, so here we are checking that with if the s is the integer and it's single, which is true, right? That means we are checking this one. Or is instance s is a slice. So if s would be the slice object, this is the slice object, and not it's single, because we have said the single is false, so not false will be true. So we are checking these conditions. If this condition will be true, then we'll set those points to the point of the polygon, to the list of polygon. Otherwise, we'll raise error as an incompatible index and the slicing assignment, right? So we are raising a 2 error over here. Now we have a correct implementations. Here we can check that we have the polygon. Here we are trying to set a single point to a slice. This will not work. Here we're getting as incompatible index and the slice assignment, right? This should not try. We are setting single object, so we are setting this list of point to the single location. This will also not work, right? Again, we are getting this incompatible error. Now let's try to do this. Here this will work. Now let's try to implement this. Here this is also working, right? Now let's try to replace with the bad point. Here we are saying that if point 0 is 0 to 2 plus 2j, so 2 plus 2j is not the real number, right? So here we should also get the error, and the error is point coordinate must be the real number. Here we have passed say that this complex number, this is not real number, right? And then we are getting the error. We can also implement the delete method and the pop method, right? Again, let's first see how the delete method work. We have this list. We are checking here. We are checking this del 0. This will delete the 0th instance of the value. When we can also delete the slice object. We can check that. We can also delete this. So again, this negative indexing is also working, right? So this del work with indices and the slice as well. Again, here for that, we have to implement the del method. Here it is, del item method. And again, this is very much because this point is a list. So we do not have to implement lot. Here we are passing the slices or the single object and pass to this list and then it will work, right? Here we are using this del of this list of the value and it is working now. Now let's create a multiple polygon. So here we have created a large polygon value, right? We are trying to delete a single object. This is working. We are trying to delete this last object. This is working. We are trying to delete the slices of object. This is also working, right? Now let's implement the pop method. Again, this is the list. So we'll again do the same pop method. We'll again implement the same pop method with the list. So here in the pop method, we'll simply call, so pop method will take the index, we'll simply call points.pop I, that's it. So here we can check that when we call p.pop1, this will delete this object, right? And it should also return the same object. Here we're getting that, right? Now the point is this, right? So this is what we have done is custom implementation of the sequence class or the sequence data type, right? Thank you very much.